Have you ever wondered what an atom looks like? What if I told you that the majority of an atom is just empty space? It's a curious thought, isn't it? Well, this is the idea that the Rutherford model of an atom presents. Ernest Rutherford, a New Zealand-born British physicist, proposed this model in the early 20th century. It was a time when scientists were just beginning to understand the tiny building blocks of matter. Rutherford's model was a leap forward in our understanding of the atom. Imagine for a moment a vast solar system. In the center, you have the sun, massive and powerful. Surrounding it, you have the planets, each spinning in its own orbit. Now shrink this system down until it's microscopic, and you have the Rutherford model of an atom. At the heart of the atom Rutherford proposed is the nucleus, a tiny but incredibly dense point, akin to our sun. This nucleus contains the atom's protons and neutrons. Surrounding the nucleus, in orbits much like our planets, are the electrons. These tiny particles are incredibly light, with their mass almost 1,000 times less than that of the protons and neutrons. But they move at high speed, creating a cloud of negative charge that balances the positive charge of the nucleus. Now here's the thing, the nucleus of an atom is incredibly tiny relative to the size of the atom itself. In our solar system analogy, if the nucleus were the size of a pea, the atom would be about the size of a football stadium. The rest of the atom is just empty space through which the electrons move. This model revolutionized our understanding of the atom. It gave us a picture of the atom that we could understand, and it paved the way for the development of quantum mechanics, a field of physics that has transformed our world. To recap, the Rutherford model presents the atom as a tiny solar system. The nucleus, containing the protons and neutrons, sits at the center, while the electrons orbit around it. Most of the atom is just empty space. This model, though it has been refined and expanded upon in the years since, remains a fundamental part of our understanding of the physical universe. So next time you look at a piece of matter, remember, it's mostly just empty space. Isn't that a mind-boggling thought?